Without further ado, I'd like to now introduce tonight's guest speaker. Mark is actually a senior systems engineer with Information Builders, and he's going to be sharing a little bit of the story about the company, but also tell you a lot about what he's actually been working on for the last 15 years or so here in the DC metro area. So I'd like to welcome Mark, and Mark, welcome.
Thank you, Hector. Thank you all. That is actually me in the picture. I didn't know they were going to use that one, but I have obviously changed my look a little bit for this summer. This evening, we're going to talk primarily about using demographic data to enrich your analytics. But before we get into that, just a little bit about who Information Builders is. We have been around for over 40 years, and we are primarily a software company focusing on intelligence, integration, and integrity. Someone's in my throat. Meaning data integrity, data cleansing, mastering, that sort of thing. Intelligence from a BI perspective, so business intelligence, analytics, predictive analytics, the whole gamut there. And that's the area that I tend to focus the most on. But in the integration area, that's all about connecting to disparate data sources. So whether it's a data warehouse or an old VAX system from the 80s, we can tap into it, and everything in between. So I'm just going to kind of dive in. This is sort of a four-part presentation. I gave this at our customer summit just a few weeks ago. And the focus on this presentation is relating to demographics. So how can you utilize demographic data in the sorts of reporting and intelligence that you do now? I'm going to start off with some things that people may be familiar with already, right? Demographic overlays. So typically, there we go, sorry. With demographic overlays, typically the kinds of things you're going to see are global demographics and business listings, population counts, projections for income, things like that. They're typically sort of the high-level, more common kinds of demographic information. They're presented as overlays for visual analysis. So if you're old enough to remember the days of the overhead projector and transparencies, right? You put one on top of another, you get kind of a different effect. It's that kind of thing. However, the difference is with the overlays, with the demographic map overlays, it's a reference. You can't interact with it. It gives you context, which is important, but it's not interactive. So things like economic development and planning, at-risk population assessment, etc. Now, in our world, we see things that look similar to this. When we talk about demographic overlays, you can see this not just in the WebFOCUS BI world, but in a lot of the other BI vendors. When they say, well, you can add other layers to your maps, they're typically looking at things like this. These are extremely useful. They're common. You've probably seen them, and they can be used in combinations of maps, reports, and charts and things like that. So in this case, we've got something that shows the U.S. median net worth for. I think that's for zip codes in this particular example, 3-digit zip codes. Okay, so those are useful up to a point, but I didn't come here to talk about that. I came here to talk about things that are a little more vast. Geo-enrichment. This is a data-centric forum, and so this is the main reason I came here is because I wanted to talk about what we can do with data. So in the geo-enrichment world, when we're talking about enriching your data, if you think about the corporate environment, and we know, especially if we're in a B2C world, we know a lot about our customers if we're doing our jobs. We know where they live, we know what they spend, we might know something about their demographic information, but we don't really know much about the people who live near them. What do we know about, you might live in a specific building or in a specific neighborhood, but does that mean that everybody that lives there is kind of in a similar demographic as you? And if they are, could they be a customer of ours as well? Those are the kinds of things you might want to find out. So when we talk about enriching your data, getting facts about people, places, and businesses, looking at a specific area or a drive time or a distance from a location. So if I've got a physical store or a physical plant or factory or whatever it might be, and I want to know within a 5-mile radius, what's the population look like? Or within, a 15-minute drive from this store, right? How many people fit into a demographic where they might be customers? So these are questions that you can ask when you start to look at demographic data. So you can pull information from as it says, these large data sets for things like population, income, housing, consumer behavior, and the natural environment. I should say, the presentation I'm giving you today, and my preferred method is to utilize demographics from ESRI. However, and the main reason behind that, it's not just that they're a partner of ours, and they are, but the main reason behind that is that it's a very comprehensive cross-section of information. In other words, we're getting census data, I'm going to get more into it a little bit. Bear in mind that what I'm talking about, you can do with other sets of data. These are more concepts than hard and fast rules that say you must do it this way. Okay? So, for population insight, we want to understand the demographic makeup. For targeted marketing, maybe I want to prioritize leads based on a certain customer type. My ideal customer owns 2 dogs and is between the ages of 35 and 50 and has 2.3 kids and spends, $100 a month on dog food, whatever it is, and likes to drink latte versus black coffee. I mean, you can find things like that out. Understand your customers better. Put together messaging that's based on their needs and preferences. Okay, so why ESRI demographics? Okay, the data comes from census and American community surveys. They've got information on things like consumer spending, market potential, the retail marketplace. I mean, it goes on and on. I'm going to show you an example in a minute. But the basic idea behind what they provide, and if you think about demographic information from a geographic perspective, if I want to look at everything within Fairfax County, okay, that's one thing. But if I want to look at everything by zip code within Fairfax County, that's a different way to aggregate the information, right? So how do I decide how to store the data and how to roll it up? Okay? They store everything aggregated down to the census block group. However, when you retrieve it, you can say, I don't want census block group, I want zip code. Or I want state, or I want county, or I want it by this polygon that I've described. So it's more of a data on demand kind of thing. So you can enrich based on point, line, or area feature, and you can use things like custom geometries. Right? At this point, since we have a small enough group, let's see if we can just get this to work. We'll jump in and do a quick example, or a quick demo. This is the, and this is publicly available, this is the ESRI Demographics browser, if you will. And there's a couple different ways to search for data. You can see these different lozenge icons here. So I can look at things by population, by health. I can look at marital status, race, housing, spending, right? If you want to see how much people spend on craft beer by zip code, you can figure that out, okay? I mean, it's kind of scary. We were talking about dogs earlier. Well, I was anyway. I like dogs. And so let's just say, so for example, how many households own 2+ dogs? You can find that out, right? Or I can say something like coffee. And I can look at maybe, I don't know, market potential for shopping, bought gift prepaid card in the last 6 months at a coffee shop. Or in the groceries, market potential, right? Use ground coffee in the last 6 months. Use Folgers. Use Green Mountain. Use Maxwell House. I don't know everything in here, but you get the idea. It's pretty granular, the kinds of things you can find out about the population. And then you can start to pull these different data elements together and paint a picture about a neighborhood. And that's the basic idea behind geo-enrichment. Now, That's cool. And just to give you kind of a different idea of, I don't think I have that slide in here, so I'm gonna take a left. We're gonna go off script for a moment, if that's all right with you all. I was talking about, let's go here. I was talking about populations and types and things like that. One of the best ways to understand how Esri looks at demographic information and how they categorize the population is something called Tapestry Segmentation. Now they have a team of data scientists. I used to live near one of them actually, which is a very interesting woman, that take all of this demographic data and they aggregate it and they run it through these different formulas so they can kind of come up with different classifications for the population. Okay? And they've got something like 13 categories, and some categories have got 4 subcategories, and some of them have like 8. All right? So what does all this mean? Let's do quick, and you can go on, you can Google this just like I did, and you can go and do your own research, but I just want to give you a quick visual example. So somebody give me a zip code.
22192.
Thank you, Marty. 22192. All right, so if we punch that in, and we'll start with the map because that's, I think, the most compelling piece. When this loads, okay, you see the different colors here, and then the highlighted one, this is 22192. All right, if we were to click on this, this should tell us. Me not. Let's go over here to the data. So it says, okay, so they changed the interface. The 3 top population segments, 40.7% enterprising professionals, up and coming people, frequently changing jobs. We rent housing, which often consists of condos, townhomes, or apartments, tend to live in lower density neighborhoods, and then you've got savvy, I can say that, suburbanites and soccer moms, okay? But so I encourage you to go and look at this. This is pre-aggregated information. In some cases, not all cases, some cases, this may be all you need. If you analyze the different population segments and you say, you know what, the people we really want to go after are the laptops and lattes. There really is a category called laptops and lattes, okay? And you can probably imagine who fits into that group. If that's what we want, okay, we go search for them. But in order to kind of indoctrinate yourself into what some of this can mean, it's a really good way to kind of get started. All right, let me go back to the slide deck here. So, I kind of jumped out at the wrong point. There we go. So we'll jump back through this and kind of get caught up to where we were. There we go. Okay. So we looked at dogs, music, and coffee. So that's all great. What can we do with the data once we get it? This is where it starts to get interesting, right? We talked about the demographic overlays, the static images, which are useful. But if we're going to extract this data, right? In theory, we know what to do with data. We can do lots of things with data once we have it locally. So what can we do? In this particular use case, we wanted to find sales potential for a geographic region. Okay, so we extracted demographic information by location. We chose to, in some cases, we pulled it by standard geography, like county and zip code. I think in this case we did. It could have been done by sales territory, a custom geography, right? We work for 2 different companies. My sales territories are going to look different than yours, probably. Could have been a distance. Show me everything within a 20-mile radius of each one of my stores, or a drive time analysis. This is what we came up with, and this is a pretty rudimentary example, but I think it gets the point across. Now, I'll kind of walk through some of these different pieces. As you can see, this is in New England, primarily centered around Massachusetts. The data is, the counties are colored based on some value. The blue diamonds represent different store locations. Okay, we have a report down here that gives us a 15-minute drive time analysis. We've got a bar chart showing us top 10 store sales potential and then some grocery store sales potential ring chart. So let's take a closer look in Worcester County. Anybody here from Massachusetts? No? I've been told I pronounced that correctly. In Massachusetts, there's no Massachusetts, it seems. People from, yeah. Anyway, here's the sales potential for that county as reported by Esri Demographics. This is the actual grocery store sales for that county. So, actual sales are outperforming projected sales countywide, not within our data. This is, a global view. Okay? And this kind of gives us the color. So if I wanted to look at If I wanted to look at the counties where we've got the highest potential sales, and then start to think about, well, how are my stores within those counties performing, right? The numbers say we should be selling 100 million a week, and we're only selling 50. What's going on? These are questions we can ask based on having this kind of data available. Now, looking at what's around us, what's around each store. This is a report that shows you, this came from the company, store number, name of the store, city that it's in, okay? Everything to the right came from the demographic data. This is the total population within a 15-minute drive of the store. Almost 31,000 people. They all have to eat. There's the number of households, 11,856. There's the median household income. Okay? And here's the projected growth from 2010 to 2016. So we can kind of analyze this and say, there's a lot of people here, and this area is growing. This store should be doing pretty well. Maybe it is, maybe it's not, right? So all of these things can be, again, because it's data and we know what to do with data, we can kind of incorporate it into different elements to help make decisions. This is a different way to look at this, where we're showing the top 10 store sales potential within a 15-minute drive. So in other words, within 15 minutes of each store, right, there's the actual gross retail, there's the sales potential, there's the gap, right? Now there's obviously other stores maybe there's other stores within a 15-minute drive of the Bedford Market Basket, but if there aren't, they're leaving over 300 million on the table. That's a big piece of pie, right? Okay, so how we do this, and you can kind of genericize this for your own environments, but basically we're building a set of metadata. We call them master files. We're building a set of metadata that's going to describe what we want from the demographic information in the cloud. We're also going to specify the aggregation criteria. In other words, I want to roll this up by zip code. I want a 15-minute drive from these 10 points, whatever it is. In order to get at this information, you must have an ESRI account. Okay, you can get a trial account with ArcGIS Online for free. Take some tutorials and start to experiment with this right now. It won't cost you a dime. But just to get started. We ETL that data down. Why? Why do we ETL it instead of going live? It's updated annually. Why pay for it every time you extract it if the numbers aren't going to change? Okay? And we then use that to geo-enrich the data that we already have. I know what my store sales are for Massachusetts. Now I know more about the population. Now I can start to do some analysis. Okay, here's some more examples. Just to kind of drive the point home and also show you some different ideas. This one's for a retailer in the Pittsburgh area. They've got a number of stores. Some of them sell furniture, some of them sell mattresses. We've got some rudimentary filtering going on the left-hand side. And then I've got some other information. So in this case, this is the same map. We've just turned on a layer that shows the population growth, projected population growth. And in this case, the darker colors are showing higher growth than the lighter colors. So based on the stores and the zip codes where the population is projected to grow a lot, right? More people equals more furniture, more beds, more children, all that stuff, right? So this was actually of great interest to them. Showing things like the annual compound growth rate for the population, for the households, for the families. Right? Just all on the map with a little info window. In that same panel, we had this chart showing the projected annual compound growth percentage within a 5-mile radius of the store. Look at Monroeville. It's going to go backwards. Right? They're projected to lose people in the next 5 years. Okay. Number of households isn't necessarily going to change too much. In actually, I'm sorry, that's projected to go up. Population is projected to go down. Okay. This one of my favorites. This is for a sporting goods retailer in the Pittsburgh area. And they were doing, how many of you played Little League sports, those of you that are younger, or have kids that play Little League sports, right? Okay, so what happens when you get involved in Little League? Parents do a lot of volunteering, right? So you have to have coaches, you have to have scheduling, you have to have uniforms, maybe you have fanware, right? You have some place where you put the schedule up. Sometimes that's a website, right? Well, what this retailer did is they said, we're going to make all that easy for you. We'll put up this space with very little effort. You can get your own website for your team, right? Pick your logo. We'll help you order your uniforms, your equipment, your fanware, do your scheduling, everything else for free. Well, guess who's selling them? Guess who's selling you the bats and balls and cleats and jerseys and pants and all that stuff? They are. So it works out. What they wanted to know is, okay, where are the best target markets, right? So a couple of things we wanted to figure out. I'm not sure if we're getting into this. We analyzed this based on what league age kids would probably look like, right? So we picked from ages 5 to 19. That might be a little wide, but that's the swath we took. And based on that, the number of kids in that age range, we then rolled them up and called them league age kids, and the darker colored zip codes show the higher concentration of that market segment. So the darker the zip code, the more league age kids you got. Okay, makes sense. And then we also broke it down so that if you click on the zip code, so Butler, PA, 6,942 league age kids participated in basketball in the last month, 1,620. I'm sorry, baseball, basketball, and football, right? Just to give them an idea, all right? I've got some other map layers on there too. We'll talk about some of those. In this one, we sort of broke it down by the population. So there's your 5 to 9-year-olds, there's your 10 to 14-year-olds, your 15 to 19-year-olds. And this kind of shows within a 20-minute drive of each one of these stores, again, retail, drive time, how far are you going to drive to go to the store versus go somewhere else and order it online. Right? That's a consideration people are taking into account more and more, especially around here. You know, how long versus how far, that's a big difference, isn't it? Okay, and you can see some of these stores have got a huge concentration of the target market segment. And then, this is one of my favorites, consumer spending. So we did a little bit of GIS magic and we figured out the surrounding zip codes within that 20-minute drive and then roll things up by zip code. So, take a look at this. 2016 consumer spending for South Hills. In 2016, almost $9 million spent on men's active sportswear. That's a whole lot of sweatpants. 10,700,000 women's active sportswear. Do you think they wanted to know about this? Okay, so this is the kind of information that you can put together. Right? It's not enough to say, well, in Pennsylvania there was $5 billion spent. Well, where? Okay, well, how about within 15 minutes of your store, last year they spent over $8 million on football equipment. That's worth knowing. That's a compelling story. This is why demographic data is important in business and government, you know. So that's all well and good, right? But what we're looking at here are single dimensions: population change, retail spending, how many kids, right? How much active sports were we sold? What if the real answer is a combination of those things? Because if you, and I know some of you are in the data science area, to do real data science, you have to take a number of different variables, run through some kind of a formula, and then come up with a result. Yeah? Okay, Hector's nodding his head, so I must be right. Okay, so let's do this. And this week, this is an actual use case we did for a client down in Atlanta. I didn't come up with the formula. Some people much smarter than me did. But what their goal was to identify which parts of the metropolitan area. We're going to talk a little bit about GIS, a little bit about marketing, a little bit about data science here. Which parts of the metropolitan area would be best suited for a specific marketing program. Now, what that marketing program was is not important. But their method was to use something called a common base statistical area. That's a GIS term. Well, it's commonly used in GIS. Think major and minor metropolitan areas. Los Angeles, San Diego, Denver, Atlanta, right? Those are all CBSAs. So it's a big block. It's a polygon that outlines the city, right? Washington, D.C., okay? Baltimore. Identify the census tracts within the CBSA. What's a census tract? It's what the U.S. Census used to aggregate population, right? And they're made up of census block groups and the smaller subset of census blocks. Okay? So that's a way to roll up data. And they wanted to just go down to the census tract level. That was small enough. It's smaller than a zip code. For each census tract, this is where it starts to get interesting. Derive the minimum and maximum values for a subgeography, okay, or for that census tract. Okay, so they're going to use the minimum and maximum for, like, let's say, age or number of cell phone users or whatever it is. I'll walk you through the formula in a minute. So the process, the statisticians, the smart people, figured out the variables that they wanted. Right? Our ideal customer looks like this, and they came up with their criteria. They said we want to know A, B, C, D, E, all these things. They then developed some formula, which basically said, okay, these things are going to be all put through this formula. However, this element is more important than that element. They use weighting. Okay. The data is harvested and aggregated. The variables are weighted. The model produces a score. Okay, and then the high score equals market success. So how does that work out? First thing we did was determine the geographic area. Now, there are a lot of zip codes in the continental U.S. There are many, many more census tracts in the continental U.S. You can't comprehend or you can't process a U.S. map by census tract. It's just not going to make any sense to you. You could probably spend hours looking at it, but it's not really going to be useful. So what they wanted to do was they wanted to roll that up by metropolitan area, CBSA. So how do we do that? For this exercise, we're going to look at the area in and around Buffalo, New York. Okay, all of the polygons you see on this map right here are census tracts. So just to give you an idea of what we started with. So we want to focus on Buffalo. We want to group these census tracts for segmentation. So what we're going to do some GIS magic and do what's called a spatial join. Right? Find all the census tracts within this big circle, this big area. It's not a circle. This is what you come up with. So this is the subdivision. The census tracts are within the metropolitan Buffalo area. Right? Everybody with me so far? All right. For each one of these variables, they wanted the minimum and maximum values for each census tract. So per capita income, population density, median age, average disposable income. These are all things you can get. Used a cell phone in the last 6 months for sports, right? Family household with a population age less than 18. Okay, fees for participant sports excluding trips, the average. So what are they paying for Little League, right? Sports rec exercise equipment, so things like that. They're going to take all those and they're going to mash them together and they're going to come up with a perfect score that's going to color these different shapes. All right, so what we did, we extracted it, we ran a report to basically come up with minimum and maximum values for each one of these different blocks, for each one of these different elements. We stored that in the table. Why? Because it's not going to change. It's an annual number. Wrote it out, and we updated it annually. Here's how the formula works. For each variable, for each census tract, the variable score, you didn't know you were coming here to do math, did you? The variable minus its minimum divided by the maximum minus its minimum is the variable score. Now the weighted score basically is this variable score times the weight. Okay? The final score is the sum of all the weighted scores. And the final score is used to rank each census tract. Yeah? Kind of with me here so far? Okay. So what you get is something like this. So there's that same major metropolitan area. We're seeing all the census tracts, but the darker the green, the higher the probability that this marketing campaign is going to have hits. It's going to have success. This is where our perfect customers live. All these dark green areas here. So this is a combination of GIS, right? Data enrichment, some programming, and some analytics. Okay.
Sorry.
Sir.
So when you talk about retail, like a lot of the topics that we've covered seem to be focused around catchment area analysis, or so when you talk about retail in this age, is there a way for you to incorporate, let's say, e-commerce data within this to actually see the sort of change or shift in consumer preferences that?
Absolutely.
Right.
Sure. Why not? Why not? I mean, if the projections say it should be this number, but our numbers, right, that we're getting from this, say it's this, right? Go back to that market, the grocery example, right? The retail number, the projected number says this. This is what our store is doing. This is what our e-commerce is doing. Yeah. Sure. The goal here is to use this to enrich your data, the data you're using now, to tell a more broad story or to help you make better decisions. Understand who you're working with. It's not quite market basket analysis, but it's kind of in the same general area, I think. Right? Knowing your customer better. Yes, sir.
So I guess to build on this question, I was curious about the communication behavior. So I know that they use their cell phones for sports, which is cool. But nowadays you can use your cell phone. You can reach your customer through several, marketing channels, email, this or that, which all come through their cell phone. So how specific could I get with their communication data? Could I see if they're using their phone for email? Could I see if they're using it for social media? Or if I could just see if they're using it for a specific industry or something like that?
I haven't done the full. I haven't gone real deep into cell phone usage, right? And I have to confess, I genericized that so that I wouldn't give away sort of their proprietary formula. So I kind of mixed up the variables. However, it's kind of scary, some of the things you can find out. I wouldn't be surprised if social media usage I know is on there. There's a few other things as well. And as I mentioned earlier, the ESRI demographics data store is not the only place to get this information. You can combine data from multiple data sources. I've talked to customers of ours up in New York that do this all the time, and they say, well, yeah, that's one thing we use, but we also use these other three. Right? But so you pick the tool, pick the data that's going to help you tell the story. Anybody else? All right, so just basically to wrap this up, kind of how this worked. The GIS team did some of the geographic work for us. They defined the geographies. They extracted the demographics. The business intelligence team did the aggregation of that data and the processing of the demographic data through the formula. And then through the information builders and ESRI integration, we were able to produce the maps to display the results and all the accompanying reports, charts, and graphs, and the interactivity. Okay. It's easier to do this than you think. As I mentioned earlier, you can, for free, establish an ArcGIS online account. I think you've got a 30 or 60-day sort of trial that you can play with. Figure out what areas you want to use for extraction. They've got an online version that will allow you to sort of find an area, extract the data that you want, okay? And then pull it down, start creating some maps and reports, and behold the wonder of your creation. It's kind of fun. I enjoy this, as you can probably tell. So why data enrichment? Just to sort of wrap things up, it gives us context. It helps us tell a better story. It helps us to answer questions for the business. It can be used for things like planning, market analysis. It helps to enrich the organization, agency, or corporate data. Okay? And if you go to one of your, if you're working for or with a customer and you go to them and say, I can help you understand your customer base better, and here's how, they're probably going to be interested, especially when we start to show them some of the numbers. Okay? Enhance the location context. Maps are really key, I think, in this. You can tell a really good story with other visualizations, but once you show someone a map, you get their attention in a very different way. I've had people look at me. I've got, as I said, I like dogs. I've got a couple of dogs. You know that look they get where they kind of go like this? That happens sometimes. You put it up on the map, and you're, wow, I know what that is. Zoom in there. Show me this, right? It changes the dynamic. It changes the interest level, and I think it stimulates the brain in a different way. That's not to demean graphs and charts because they're extremely valuable communication tools, but when you combine them with a map, you get a different message. You give a different message. Leverage your in-house GIS efforts if you've got them. Leverage your BI and ESRI integration. And that's it. That's what I've got for you tonight. Any questions? Other comments? Do we have another hour to fill? I can talk about other stuff.
You're right on time.
I'm on time. That's great. Yes.
Does this, so if there's any independent tool, can your data be used? Does it let you?
The ESRI, yeah, I don't work for ESRI. They're a partner of ours. That data can be used by anything. So it's really a question of selecting how you want the data to be aggregated. Do you want to see, income and population by state for the entire U.S. or for Canada or for Europe or whatever, and pulling the data into a format that you can then consume? So you can do this with other tools. With our tools, it's easier, I think, but there's nothing to say you can't create visualizations against data because data is data.
So what kind of visualizations does your tool have? Like, is it?
Funny you should ask. No, we'll just go back to. Let's see where the best. All right, this is an example. This is one page, and this is actually from a portal. So this is one HTML page where I've got, and you can kind of, I happen to lay it out like this because I felt like the map was the most important thing. But this map is an HTML5 panel that fits into this page that uses the ESRI WebFOCUS integration. The data is painted live, so if the data changes, if we delete a store, the dot goes away. If for some reason, let's say these counties were shaded by sales instead of population or retail, whatever it is, right? As the data changes, the visualizations will change, just as they would in the report in the two charts.
So when you said the data changes, do you have the parameter up here that we can change and the display will change?
This example is not parameterized. I've got lots that are. So the user can choose a set of filters, can say, give me time series, right? Or I want to look at the first 2 weeks of October between the hours of 2 and 4 p.m. Whatever it is. Yeah, absolutely. Very easy to put together without coding. That's the best part.
Thank you.
Sure. Yeah.
Yeah, I have a question about data, more specifically on its accuracy. So of course you're collecting data from multiple resources, census and others.
Mm-hmm.
Some of them are very detailed into, almost like personal tracking, what you said, can get scary, right?
Yeah.
And from the visualizations and the presentation that you shared, I saw very exact numbers down to a dollar point or down to an individual, and these are generally estimates, I believe. So how accurate is the data? And I mean, it's a maybe open-ended question, but I guess a lot of tools are not necessarily conveying that uncertainty behind the data because all of them are, you know, but then now you put 2.3 or, you know, a specific dollar amount to the cent, it looks so, to be, you know, it looks so accurate. So is it accurate and how accurate it is?
I can't speak to from let's see. I don't speak for Esri. I have used their data. I've done some research against how accurate it is compared to others. One of the reasons I used it, rather than aggregating 2 or 3 different disparate data sources, is that they don't certify it. They do a lot of science against it to make it as accurate as they possibly can. Okay. Should you put up a disclaimer to say that these are the best estimates that we can get, especially when you're looking at projections? Maybe so, yeah.
And how close, or, you know, do you have some experience working with certain variables, saying this is within 10% range or 20% or 30%, you know, because those kind of estimates can make a big difference in deciding where you want to go if the data is not that dependable. So do you have any examples about how accurate the information gets?
I'm not the right person to ask. You'd have to speak to Esri about that. You know, if you Google Esri demographics, it'll take you to that doc page that I showed you, and there's one of the sub pages or one of the other choices in there goes into their process, the studies that they've participated in to show how accurate it is. It should give you at least enough information to decide what questions to ask them and what ask them.
And census is publicly available.
Yes, census is, as is American Community Survey information, I believe.
Oh, okay, so all of them.
Yeah, and they use those two primarily for a lot of the high level stuff, but a lot of the other information I think comes from, gosh, I can't remember. They list a lot of their sources though, so you can get into it by going to their website.
One
Yes.
last question and we can wrap up.
Okay. Yes, ma'am.
Have you compared your software with another software that's available now in the market?
I have, and ours is superior in every way. Do you have one in specifically that you're interested in? Or?
No, I just wonder because if you want to claim that you're superior, then you should compare.
We do. I have a component in New York whose job it is to analyze the competition and to sort of show how we stack up. We also participate in a lot of analyst surveys and analyst studies. So Forrester Research, Gartner, Dresner, yeah, they've all got data on us. In terms of the GIS integrations, I have analyzed a lot of our competitors. I feel what we're doing is superior for a number of reasons, not the least of which is the ability to do things like this with multiple map layers. There are other people out there doing it. However, typically that involves a lot of back-end coding, right? Where we can produce this using our tool set without having to open up the hood and handwrite a bunch of stuff. Right? Anybody, you can JavaScript it all day long. It's more user-friendly. It's a lot. You can build something like this a lot more quickly. In the GIS space, in the BI space, I don't know what to say. We categorize typically as an enterprise software company. We do compete with SAP. We compete with Burst to a certain degree. Help me out. I'm listening.
We don't see concepts anymore. We don't see business objects much anymore.
Used to be, occasionally MicroStrategy.
Studies that they do, there's generally categories that they use to rank, and they're all based upon customer responses. So when you look at Dresner, for instance, he comes out with it every year, and we're consistently in our share group ranked the highest all the way around with all the.
So for example, like Esri data, for example, is it like you're the only guys who has the aggregation and all those things, or other players in the market?
But we're the only ones in the market that offer the intelligence, integration, and integrity.
Yeah, thank you.
Great. Mark, I want to thank you for a great discussion. And audience, if you have any follow-up questions, Mark, I don't know if you're going to be here for a little while. I know he wants to go and watch the game, the hockey game tonight. So he's in a kind of a rush, but you can actually get a hold of him. Also, raise your hand if you're with information builders. You know, the folks, Daniel and I'm sorry, Marty. You know, so feel free to ask any questions, any follow-up questions. If you have any, they'll be here. And I want to thank you, Mark, specifically, and everybody at Information Builders for a great discussion today.
Thanks.
All right.